How's it going, everybody? In today's lesson, we're going to look at 5.4, which is all about real world systems. We got 4 steps to solving these problems. Step 1, define your variables. Step 2, choose your method. Step 3, solve your system. Step 4, answer the given question in context. That means that we have to use units on our answer, and that's where defining your variables becomes very important. So in example 1, Ted is 1 year older than twice Kelly's age in years. The sum of Ted and Kelly's age in years is 49. How old are Ted and Kelly? So first of all, we're going to want to define our variables T and K. So one way that you can tell what your variables should be is to look at what the problem is asking for. So the problem asks for the age of Ted and Kelly. That means that that's what my variables should be. All right, so T is going to be Ted's age and K is Kelly's age. All right, and now I've got to figure out how to write 2 equations here using this information. So it says Ted is 1 year older than twice Kelly's age. So if I translate that into an equation, Ted's age is equal to twice Kelly's age plus 1. So twice Kelly's age in years, and he's 1 year older than that. So 2K plus 1. And then the second part there, the sum of Ted and Kelly's age in years is 49. So that means that T plus K must be equal to 49. So now I've got my system of equations. And as you can see, I already have a variable isolated right here, T. So it is going to be very easy for me to take this statement, 2K plus 1, and substitute it in the second equation for T. So substitution is the method that is probably most appropriate here. So if we make that substitution, it's going to be 2K plus 1 plus K equals 49. Here we're combining like terms, so 3K plus 1 equals 49. Subtract 1 on both sides, 3K equals 48. We're just solving the equation the way that we've been solving. 48 divided by 3 is 16. So K is 16 years. So Kelly is 16 years old. All right, there is one of my answers, one of my variables. Okay, now I'm going to take that, K is equal 16. I'm going to take that and substitute it back into this top equation that's already solved for T. So to find Ted's age, it's going to be T equals 2 times 16 plus 1. So that's going to be what, 32 plus 1. So Ted is 33 years old. So notice that I'm using my units, years, and we're talking about age, so we say years old. And that's how we find Ted and Kelly's age based on that information. So bunch of different types of examples you can see in this section. So example 2, this is kind of a common one, deals with items that were purchased and money, cost for those items. So Meg paid $26 for 2 books and 2 games. Meg's sister paid $28 for 4 books and 1 game. That's where my 2 equations are going to come from, is this information here. And the more of these you do, the more you'll be able to recognize that. So that's going to be the information I use for my 2 equations right there. So each book costs the same amount, each game costs the same amount, which means we can define them using a variable, their cost as a variable, And it says, how much does a book cost? How much does a game cost? So again, you know, whatever the problem asks you for, that is what your variables should be. So let's go ahead and define those. So how much does a book cost? So we're going to say B is cost of a book, and G, cost of a game. All right. Both of these variables are measured in dollars, okay, because we're talking about cost. So if you take a look at the yellow highlighted part, it's $26 for 2 books and 2 games. So if you think about it, 2 books times the cost of a book, so 2 times B plus 2 times G, so 2 times the cost of a game. If you add those 2 things together, what that statement in yellow is saying, if you add those 2 things together, it should be $26. And there's my first equation. So to get my second equation, I'm going to go to the blue highlighted part, very similar type of math statement. So it's 4 books and 1 game. So 4 times the cost of a book plus 1 times the cost of a game. That should add up to $28. And notice again, we don't have to put the 1 right there in front of the variable. Okay. So this problem here, you kind of have options as to you know, whatever method you want to use to solve it. I'm going to go with elimination here just because it seems like a decent choice. So I can actually multiply, you know, a bunch of different ways you can do this, but I can actually multiply that bottom equation, both sides times -2. That's going to allow me to eliminate G. All right. So I'm going to get, let's rewrite this. So the top equation stays the same. And on the bottom, I'm going to get -8B minus 2G equals -56. So now with my green equation, I can actually add those 2 equations together, just like this, and my G variables eliminate, okay? So it's going to be -6B on the left. On the right, it's going to be -30. And if we solve that, we can see that B is $5. All right. And so, you know, I know that there's a lot of people that put the $ after the 5. That's actually incorrect. Okay. When we talk about money in America, the $ goes in front of the number, just like you see in the original problem. So let's make sure that we do that the right way. So we got $5 for B. All right, we can go back and find the cost of a game fairly easily. Actually, I'm going to use this equation from the original just because the G has a coefficient of 1. I know that's going to save me a step. So let me go ahead and get green right here and substitute 5 for B. So it's going to be 4 times 5 plus G equals 28. That's going to be 20 plus G equals 28. Subtract 20 on both sides. We got G is $8. So the price or cost of a game is $8. So that's how that example goes. Yeah, so we're finding both of those variables that we defined. Here's another common type of example here in example 3, the savings account type of problem. So you've got 2 people. You've got Bruce, and he has $150 and saves $20 a week. You've got Katie, who has $200 and saves $10 per week. And the question says, after how many weeks will they have the same amount of money? And not to mention, we also have an additional question that says how much money is that, like how much money do they actually have? All right. So the interesting thing here is you may be led to, create a variable for Bruce's bank account and a variable for Katie's bank account that are separate variables. And you could do that. But what you have to understand is those two variables are not going to look the same, and they're not always going to be the same. But to answer this problem, we want to know when are they the same. So it is kind of easy to just go ahead and say, define M to be the amount of money in the account, and W to be the number of weeks. So we know that regardless of whose account it is, the amount of money in the account is the same, or it is a function of the number of weeks. And it's going to take, we got to find out how many weeks it takes for them to have the same amount. So that's why, again, it makes sense to define that variable for the amount of money in the account as M, make it the same for both of them, just because it makes a little bit more sense mathematically. We could say, here is Bruce's account and here is Katie's account, but eventually we would have to set these equal anyway. And that doesn't really match what we've been doing in Unit 5. So that's why we're doing it that way. So anyway, let's start with our yellow highlighted part. Bruce has $150 and saves $20 each week. So we can actually write that. We can say M equals 20 times the number of weeks. So that's $20 each week plus the $150 he already has. And then the blue highlighted part, we can do something similar for Katie's account. We can say, the amount of money she has equals $10 each week.
Good morning, almost afternoon, Gilbert High School teachers. As you saw the email from Dr. Little a little while ago.
Sorry,
so
guys.
If you have received an email from DPugle with concerns about your grades, please get that smoothed out, and Dee can help you with that before leaving campus. If you've not received an email from DPugle and your grades have been submitted, and you are ready for the start of second semester and gotten everything wrapped up, I hope you have a great long weekend. Stay safe in the ice apocalypse, and we will see you next Tuesday. So enjoy your weekend, teachers, support staff. We've communicated to you about how we'll be handling the rest of the day. So please follow through with what's been communicated to you. But otherwise, teachers, have a great long weekend, and we will see you on Tuesday. Bye-bye.
All right, well, that made this video a lot more authentic, so that's nice. So anyway, $10 times the number of weeks plus the 200 Katie already has saved. And so I guess one way to think about this problem is kind of just like substitution, right? So you're setting these two statements equal. All right, I think mathematically the best way to think about that is substituting 20W plus 150, substituting that for M in the bottom equation. So just like that. So let's go ahead and write that out. So 20W plus 150 equals 10W plus 200. All right, I got variables on both sides. We all know there's a bunch of different ways to do that. Moving that variable term right to left, so subtracting 10W on both sides is kind of the way to go here. So at this point in Algebra 1, we should be able to follow that pretty easily. All right, and subtract 150 on both sides, of course. So it's going to be 10W equals 50 W equals 5 weeks. Okay, now we got our number of weeks. So after 5 weeks, you know, Bruce and Katie will have the same amount in their bank account. And so the problem asks, you know, how much money is that actually? They're asking you to find M. So we're going to take 5 and we can actually substitute it back into either one of our red equations up there. I'm just going to do the bottom one, I guess. So it's going to be M equals 10 times 5 plus 200. All right. And so that's going to give me what? 250. So $250. That's how much money they have in their account each, whenever the amounts in the accounts are equal. Okay. So similar type of example here in example 4. Matter of fact, if you want to pause the video and try this one on your own, that would probably be a good idea. So go ahead and pause the video now. Whenever you press play, the answer will be up here and you can check your work. All right, so let's go ahead and take a look at example 4. Here is my solution. Basically, you're trying to find the cost of the bath towels and the cost of the hand towels. Obviously, the units then are going to be dollars. So when you set up your 2 equations, I found elimination to be the kind of the quickest and easiest method of solving this. Remember, you could use substitution if you really wanted to. I ended up getting $12 for the cost of a bath towel and $8 for the cost of a hand towel. So if you have any questions about this lesson, please let me or Miss Buchanan know. Y'all have a great day. Stay safe.